Hello and welcome to Electronic Olga. In this video, we're going to talk about different circuit. This circuit works with power uh, water sensor that access to the ADC of microcontroller Stm32. And here I want to load the file I done before, and I want to explain that for you. I load the project. This is my project, water level project. And let me bring it for you. Okay, this is my project. I did that before, and this timer 2 channel 1 is not really necessary for this project, and this pin PA1 is for ADC pin. That sensor is sending its output to this input of the microcontroller, and this PA13 and PA14 is for something programming this microcontroller and is automatically configured here. Here in the system core, we access to sys and we make our debug to serial wire. And in the RCC, we have a blue pill board, so we use the crystal ceramic resonator. In the NWIC, we have nothing. For the ADCs, for the ADC1, we left everything as usual, but the NWIC settings, we use the ADC1 and ADC2 global interrupts. We want to use the interrupt to get the signal from the sensor, water sensor, and we use that interrupt. Okay, let's go for it. Okay, after doing this, we come to here. We select here, generate code, and after our code generated, we're going to Cube IDE, and we have here our code here, water level, and the core. In the core, for example, source, you have main.c file. In the main.c file, we actually done something really important. I want to explain that for you. Here we have ADC handle type def HADC1 that was automatically created by the CubeMX. Here we are initializing the GPIO ADC, and this is timer 2 that was really not important here for this project. In the main file, we have Hall in it, and the other functions here are GPIO init, ADC init, timer 2 init. That I said that is not really important here. After that, we really want to start the PWM. That is not really important here as well, and this is really important to set this line Hall underline ADCEX underline calibration underline start for the ADC1. This will calibrate the start point of the ADC, and there in the while loop we have nothing. Yeah, we have nothing, and at last here somewhere in the code, okay, as you can see here, here the value is about 2, 3, 4 is changing. This is the ADC values that is changing, and I want to describe the code again for you. We have the value parameter that we describe or identify it for 0. Then we have the ADC number 1 and timer number 2 that is used for this project is defined by the CubeMX, and these codes are defined all by the CubeMX. And in the main file, we add another hall underline timer underline PWM underline start. This is for timer 2 start. For channel 1, we use this. And another code is for hall underline ADC calibration start. This is for calibrating the ADC for our use. And in the while loop, we start the interrupts. Start the interrupt for ADC 1, and timer 2 CCR register is being updated after 1 millisecond delay, and after any callback of the conversion complete callback. This is for the time when the ADC is converted and its conversion is completed. And when the conversion is completed, the value is being updated in every conversion configure setting. And this whole underline ADC get value is updated, the value parameter. And then we can see the parameter value here. Okay, here is as you can see is 4 3, and is changing because its sensor is dry. And now I want to put it in water, and when I put it in water, you can see that it's going to 1000, and I put it back, it's going down, and I put it in the water, it's going up. I think when I putting more in the water, it's going to 2000, 2000, for example, look at see 2000, and then I put it out, its reading value is going down, and it's showing that we are going straight ahead. Okay, and now I want to describe you the Arduino code. I write it for my Stm32 project. This is the analog pin PA1, that water sensor connected to analog PA1. LEDs, I used 3 LEDs, PB9, PB11, PB1, and that are identified here. In the setup mode, we pull down the LEDs, and in pin mode, we describe our LEDs as an output LEDs. In the loop, we are going to have 3 ifs, one if for 1 LED each, and in the if we are just comparing the value that we described before, and it's a number that's a signal to the microcontroller, and if digital write, we write an high in the microcontroller pin, and we load the 2 other ones in the other. Else if parameters is the same, but we hide that a specific LED, and after that you're just having fun with our project, and have we are going to have a look at that in the next part.